Alright, so we just finished up looking at fluorine's orbital rotation in the previous assignment, where we're going to look at what are called electron configurations now. So this is the orbital rotation for fluorine. Electron configurations are kind of a condensed version of that. You know what condensed means? If I have condensed milk, what is that? What? Concentrated it. We took out some of the water. Okay? So we're going to concentrate it a little bit. We're going to write the symbol for fluorine. We're going to write the 1s on the same line with the fluorine. And we're going to count the number of electrons in that S sublevel. And that's going to be a superscript. How many electrons in the 1s sublevel do we have? 2. Superscript 2. And so this is 2s. How many electrons in 2s? 2. How many electrons in 2p? So write that one now. How's that? Does that seem all that hard? Well, it is a little shorter, but what it does, there's some things it doesn't show you. It doesn't show you the spin of the electrons or where the electrons are located in orbitals. Okay? Which is kind of important when we start looking at the structure of ions and such. Okay? Now, fluorine is almost full up here, isn't it? Let's look at the next highest noble gas, neon. Look on your periodic table at neon. Okay? I need one more electron in fluorine for it to be have the same electron configuration as neon, don't I? And you know what? Neon is stable. Okay? Atoms tend to be stable. Atoms tend to be stable when they have a full valence level of electrons. So I'm going to redraw fluorine over here, as I would suggest you do. In order to make fluorine as stable as it can be, it would like to have an electron here. Now that creates in itself a kind of instability we'll talk about resolving later. Okay? But if I put an extra electron in there, that's not a fluorine atom anymore. If I put an extra electron in there, I have one more electron than the protons in the nucleus. How many protons in fluorine's nucleus? How many electrons in fluorine's nucleus? 9, because the proton number says 9 here. Okay, the atomic number says 9. How many electrons do I now have in this version of fluorine? So what is the actual charge on this? -1. So the fluorine is not fluorine anymore. It's a fluorine ion we call a fluoride. Oop, I misspelled it. F-L-U-O. It's like you switch around the O and the U in flower. This now becomes, instead of being fluorine, it becomes fluoride because it has a charge, has a negative charge. So negative monoatomic ions, that is, there's only one atom in size, negatively charged ions that are a single atom in size, we change the ending of the name to IDE. Okay, so it's a fluoride ion. Got that?
So it's only that one ion, fluoride.
Well, yeah, fluorine only has one ion, but you can have more than one ion sometimes. Okay? We're only going to deal with those that are pretty simple like this. Got that? So how many electrons is oxygen going to want to have? How many electrons is oxygen going to want to have? No, it's going to want to have 10 too to be full up. If I have 9, I'm going to still have an empty place over here. That makes sense?
So the 2p is going to be 2p6.
Yeah. It'll have the same orbital notation, electron configuration, as neon. Mm-hmm. And one last thing, this actual symbol for fluoride is F negative. If it was a 2 negative, I'd put a 2 there. If it was 3 there, I'd put a 3 negative. Does that make sense? Okay, so we're going to name the ion for oxygen, and we're also going to write the ion symbol. Okay?
So the ion symbol